Hello everyone. Today I am going to discuss the chapter 1 of chemistry, chemical reactions and equations. Let's start. Chemical reaction. Chemical reaction, a process in which reactants react to form one or more new substances. I said in which reactant react, it means one or more substances react to form new substances. That is, chemical reaction always consists of two parts. One, that substances that react, and the other, the new one is formed, is called product. For example, when sodium hydroxide react with hydrochloric acid, NaOH and HCl, when they react with each other, they form NaCl, sodium chloride and water. And now you can see NaOH and HCl, they react. That's why they are called reactants. And NaCl and H2O formed are the new substances after their reactions are formed. These are called products. And we can say that it means that chemical reaction always consists of reactants and products. Left hand side reactants and right hand side products. Now the next is chemical equation. Chemical equation. I will explain you with the help of one example. For example, if I say when magnesium ribbon is burned in oxygen, it gets converted into magnesium oxide. Now when I speak this sentence, it means the chemical reaction takes place, but it is very lengthy to speak all the reactions. That's why we can represent in this chemical reaction in two ways. One, in the word equation, magnesium plus oxygen react and form magnesium oxide. But if I represent this chemical reaction and this word equation in brief and in shorthand form, in the form of symbols and formulas, if I write the symbols and formulas of reactant and products, then it is called chemical equation. So what is chemical equation? Brief and shorthand representation of chemical reaction in terms of symbols and formulas of reactant and product is called chemical equation. I will represent this chemical reaction in the form of symbols and formulas. Magnesium, Mg, oxygen, O2, and when they react, it means these two are reactants, and when they react, they form a new compound that is called magnesium oxide, and its formula is MgO. Now this is chemical equation. I'll write this chemical reaction equation again. Magnesium plus oxygen, magnesium oxide. As you can see, that is according to the law of combination of mass, the mass should be equal on the reactant side as well as on the product side. That is, whenever a chemical reaction will take place, the number of atoms of each element before the reaction and after the reaction should remain same. But if you will see this chemical equation, if you will check the number of atoms of each element, this chemical equation, these are not equal on the reactant side and on the product side. Now we have to balance this chemical equation, and now I will tell you how to balance the chemical equation. That is, how to make the number of atoms of each element on the reactant side and on the product side equal. Let us balance this chemical equation. You can see magnesium. First, what you have to do before starting the balancing of chemical equation, first keep all the elements and formula in a bracket so that you will not make any change inside these brackets. Now you will make a table, and that you will write each element that takes part in the chemical reaction, and then you will write the number of atoms on both the sides. Now, first element magnesium, second one is oxygen, then magnesium Number of atoms of magnesium, you can see if there is nothing is there, then it is 1. Then oxygen, O2. It means number of atoms of oxygen, 2. Now on the reactant side, right hand side, magnesium, 1. Oxygen, 1. Now you can see this chemical equation is not balanced because oxygen atoms on the left hand sides are 2 and on the right hand side is 1. Now we will balance this chemical equation. Now how we can balance? The number of atoms of each element on the left hand side and the right hand side are not equal. This is called skeletal chemical equation. Unbalanced chemical equation is called skeletal chemical equation. Now we have to balance it. Now balance it. 2 Mg plus O2, that is 2 MgO. This is called balanced chemical equation. You can check the number of atoms on both the sides of each element are equal. Now I will explain you this one more example. For example, iron, Fe, when react with, that is a water, in here H2O, that is in gaseous form, that is Fe3O4 pyric oxide and hydrogen gas is evolved. If I balance this chemical equation, first step what I will do, I will put all this in bracket so that I can't make any change inside these brackets. Then I will write each elements that take part in the chemical reaction. Here first one is iron, Fe, second is hydrogen and the third one is oxygen. Now let's check the number of atoms. Fe on the reactant side, number of atoms 1, hydrogen number of atoms 2 and oxygen that is 1. Hydrogen 2, then oxygen, here oxygen 1 and here oxygen on the right hand side 4. Now this is our skeletal chemical equation. Now we will balance it. Now first Fe3O4. Look at this formula Fe3O4. Now here the number of atoms of iron 3. Now what I'll do to balance it, I'll put here 3 Fe. Now iron is balanced. Now oxygen 4. Oxygen 4. What to balance oxygen? What I'll do? 4. Oxygen. Now oxygen, this 4 is both with hydrogen as well as with oxygen. Now oxygen is also balanced. Now here you will see this 4 is both hydrogen also. Now the number of atoms of hydrogen, that is 4 here and H2 here. Now the number of atom here is 4 into 2 is equal to 8. Now here are only 2. Now we have to balance this hydrogen also. Now why I will balance, that is 4 H2. Now hydrogen also here 8. Now let us check it again. Fe here 3. Here again 3. Now hydrogen 8. Here hydrogen 8. Both the side 8. Now here oxygen 4 and oxygen 4. Now you can see this is balanced chemical equation. Now we can make our chemical equation more informative. How we can make our chemical equation more informative? That is by writing the physical state of elements and compounds. For example, if it is a solid, we will write S, liquid L, gas G. If it is aqueous, aqueous means that is the solution in water, that when the solvent is water, then we'll write AQ. Then let us explain it with the help of one example. The same equation I am taking, Fe, that is solid. I'll write here solid. When steam is passed over, I'll say steam is passed over iron. It means water is there, but that is in which form? That is in gaseous form. If the water is in liquid form, then we will write here L. But the steam is passed over the iron. It means water is in gaseous form. I'll write here G. Then Fe3O4, that is again solid, and 4H2, that is gas, that is hydrogen. I'll write here G. And one more thing, whenever in any chemical reaction there is an evolution of gas, we will also represent it with the help of this upward arrow. If this arrow is there, it means in that chemical reaction there is an evolution of gas, and in this reaction hydrogen gas is evolved. One more, that is a sometime whenever we write the chemical equation, and to make the chemical equation more informative, we'll write here the reaction conditions. For example, temperature, pressure conditions, catalyst that is the substance that take part in chemical reaction but not involve itself, that is called catalyst. And we'll write that all the reaction condition upward or below this arrow. For example, CO gas, 2H2 gas, 340 atmosphere, this is pressure condition. It changes into CH3OH, that is liquid. Now, if a photosynthesis, you all know about the photosynthesis, that the process of food making process in plants, that is called photosynthesis, and we can represent this photosynthesis with the help of this chemical equations. Because in photosynthesis, carbon dioxide and water are used, they react with each other. Carbon dioxide, aqueous, H2O, liquid. Now it takes place in the presence of sunlight and chlorophyll. What is formed? C6H12O6, glucose, aqueous, then 6CO2, again aqueous, and water, that is liquid. Now when we write the physical state of elements and compounds that make, and sometimes the reaction conditions, this makes our chemical equation more informative. Now one more thing, that whenever a chemical reaction will take place, you have seen here, whenever a chemical reaction will take place, there are few changes take place. That is, sometimes there is an evolution of gas, change of state, change in temperature, and sometimes change in color take place. So whenever chemical reaction occur, these changes can take place. Evolution of a gas can be evolved, a state can be changed. For example, if I give you the example of state, H2 gas, O2 gas, but when they react, what they form? H2O, that is liquid. Change of state. Evolution of gas, I have given you the example when the steam, steam is passed over the iron. One more example, when zinc reacts with sulfuric acid, what is formed? ZnSO4, and hydrogen gas is evolved. And sometimes there is a change in temperature that I will discuss you during the, that is exothermic and endothermic reaction. This is all about the what information and what type of changes takes place when there is chemical reaction. Thank you.